गुड मॉर्निंग स्टूडेंट्स। आज का हमारा टॉपिक है फैराडेज लॉज ऑफ इलेक्ट्रोलिसिस। Faraday studied the process of electrolysis and on the basis of observations he formulated two laws in the year 1833-34. So in case of electrolysis, when current passes, the electrolyte dissociates into cations and anions. At the cathode, which is negatively charged, positively charged cations move and take up electrons and get discharged. Similarly, at anode, the negatively charged anions move, they give electrons and get discharged. It's the basis of Faraday's first law of electrolysis. The law states that amount of any substance deposited or liberated at any electrode is directly proportional to the quantity of electricity passed through the electrolyte. The electrolyte should be in solution form or molten form. Now, if W is the grams of substances deposited at electrode and Q is the coulombs of electricity passed through then the weight of the substance deposited is proportional to the quantity of electricity passed. Q, coulombs of electricity. W, just to remove the sign of proportionality, we put a constant Z. Z is the constant of proportionality called electrochemical equivalent. So W relation becomes W is equal to Z into Q. If a current of I amperes is passed for T seconds, then quantity of electricity or charge will be Q is equal to I into T. I is the current in amperes, T is the time. Now W, we know W is equal to Z into Q, or W is equal to Z into I into T, because Q is I into T. Now in this relationship, if Q is 1 coulomb, or in Q I is 1 ampere and time is 1 second, then the relation W is equal to Z I T becomes W is equal to Z, because I is 1 ampere and time is 1 second. So from here we can find out the definition of electrochemical equivalent. It is the weight of substance that is liberated or deposited when a current of 1 ampere is passed for 1 second. It is called electrochemical equivalent. This is the first law of electrolysis. The relationship is W is equal to ZIT. The second law of electrolysis states that when same quantity of electricity is passed through different electrolytic solutions connected in series, the weights of substances produced at the electrodes are directly proportional to their chemical equivalent weights. For example, if these two electrolytic cells, they are placed in series, same current is passed through them, then the weight of copper deposited upon the weight of silver deposited silver, or equivalent weight of copper upon equivalent weight of silver. Weight of copper deposited upon weight of silver deposited is equal to equivalent weight of copper upon equivalent weight of silver. The amount of electricity needed or amount of products formed can be calculated from the equation of appropriate electrode reaction. For example, if it is a copper electrode, then copper ions will take 2 electrons to form copper solid. So you can see that to deposit 1 mole of copper, 2 moles of electrons are needed. Now charge on 1 electron, you know it is 1.602 into 10 raised to power minus 19 coulombs, and 1 mole contains 6.022 into 10 raised to power 23 electrons. So charge on 1 mole of electron will be charge on 1 electron multiplied by number of electrons in 1 mole. 6.022 into 10 raised to power 23 into 1.602 into 10 raised to power minus 19 coulombs. On solving this, the answer comes out to be 96485 coulombs for 1 mole. Now this is approximately equal to 96500 coulomb, rounding up. So the charge on 1 mole of electrons is called 1 Faraday, in honor of Michael Faraday. And charge on n moles of electron will be n into F. So to produce 1 mole of copper at electrode, 2 moles of electrons are needed, that is 2 Faraday charge. You can see this from this equation. To deposit 1 mole, 2 Faraday charge is needed. That is 2 into 96500 coulomb, because 1 Faraday is this much coulombs. Similarly, aluminium equation is aluminium ions will take 3 moles of electrons to form 1 mole of aluminium. So the charge needed will be 3 Faraday, or 3 into 96500 coulombs. So from the knowledge of moles of electrons required during the reaction, amount of substance deposited or evolved can be calculated. Consider an experiment in which same amount of current is passed simultaneously through 3 aqueous electrolytic solutions connected in series containing aqueous solution of silver nitrate, copper sulfate, gold chloride. So how much of these will be deposited on each electrode? So silver's equation is 1 mole is needed to form 1 mole of silver. So 1 mole of silver will be formed if charge equal to 96500 coulombs is passed. If for copper 2 moles are needed, so 2 moles are needed for depositing 1 mole. So with 1 mole only half mole of copper will be deposited. And similarly with gold, because 3 moles of electrons are needed, only 1/3 moles will be deposited with 1 mole of electrons. So the same amount of electricity or same amount of charge if is passed through the 3 electrodes connected in series, they will deposit substances in ratio of their equivalent weights. Equivalent weight is their molecular weight divided by the number of electrons involved in their equations, electrode reactions.